Let's look at how to do a two-sample, an independent t-test, when all the data is in one column. In Excel, we want to separate the data into two columns when we want to compare two groups. What do we mean by this? Let's look at this data from one of my classes where I asked people how much they like Star Wars. And they answered from a scale of 1 to 5, where 1's not very much, 5 is quite a bit. And then in that same survey, I asked them their sex, if they're male or female. 1 is male and female is male. Now, suppose we want to test the hypothesis that there's a difference in preference for Star Wars between the sexes. So our hypothesis would be males and females appreciate Star Wars differently. And we're going to test to see if on that 1 to 5 scale, if it's statistically different or not. So this is a two-tailed test, because we're just saying it's two tails, because we're not saying that men like Star Wars more or females like Star Wars more. We're just saying that's going to be different. So what we need to do is we need to get the data into two groups. Now, I have this in a table where Star Wars is one column and sex is the other. What I need to do is I need to sort by the groups. So I'm going to sort by sex. I'll go from smallest to largest. So here I have all the 1s together and now all the 2s together. And so we can copy this into a new table. So I'll copy all the male scores. So I highlight them, arrow down, Control copy, and then over here I will put them, Control V, and I'll label this males. In the next column, I'll label females, and we'll copy all the data for females. Because when this sorted the data, it kept all the lines together. That's one of the properties of these tables and with the sorting arrows on them. So let's choose all the female scores here. So I'll start there with the first two, and I'll go down and shift arrow key to get them all. Control C for copy. Now put them under females. Control V. And there we have the data in two columns. Now I'm going to make this into a table. The way that I make it into a table is I go to Insert and then press Table. I need to make sure that the highlighted cell is in there, the selected cell. I press Table, and it says, is that what your table is? And I said, yep, that's what I want. And my table has headers. Yes, those first two columns are not data, they're headers. So I press OK. Now I've got a table there. Now, with this data, I can do the independent sample t-test. So I go to Data and Data Analysis. And if you don't have Data Analysis up here, that means you need to install the Data Analysis Toolpak, and you can find the video on how to do that. It comes free with Excel. So I click Data Analysis, and I go down to t-tests, and I want to do two sample, assuming equal variances. Press OK. And it says, what's the first variable? And I'll put the males in, and I'll select the header, the label. Then I'll go to the second variable, and I'll choose the females. Now, it's fine that they don't have the same number of data. T-tests work fine that way. And then for this two-sample t-test, we always put 0 for the mean difference. And we have labels in that first row. And for the output range, I select output range, and I'll click into there so that when I click into the next box, it goes in there. And let's put it right there. And we do OK. And we have a t-test result here. And it looks pretty nasty. So let's round off the digits to 2 decimal points by going to Home, Number section, Number. Now let's make this one title, or this one column wider so that we can read everything. And so what do we have here? the results say that the mean is 4.1 for males and 3 for females. So it looks like males are higher than females. And the question is it significant? So we look at our t-stat, and it's 1.95. Now we made a two-tailed test, so we have to use the p for the 2 value, and look at that, it's 0.06. So it's not significant. Our hypothesis was not supported. Now you might say, well, can't we go change our hypothesis? No, you can't change your hypothesis after looking at the data. That's unethical because it leads to what's known as alpha inflation. We know that when we say that the p critical value has to be, the t critical value has to result in less than p less than 0.05. We know that when we choose that, we're going to make an error 5% of the time. Now, if we go around, so that means if we made 20 hypotheses, we'd expect one of the 20 to be wrong. Now, if we keep guessing at hypotheses until we get something right, we're going to just keep increasing that alpha value until we're almost sure to get something right that's just random. So the solution to this is whenever we do research, we should study, who likes Star Wars more, males or females, so that we'd be able to make a directional test. Here, our test was not, our hypothesis was not supported, and further studies would need to be done to verify that males like Star Wars more than females. For example, we'd need to get new data so that we wouldn't be, if this was due to chance, we wouldn't be increasing we wouldn't be building upon that chance. We'd be dealing with more new data where there's only, once again, a 5% chance of error.